When we look up at the night sky, we see stars, galaxies, and nebulae. But what if I told you that the visible universe is just a small fraction of what's really out there? Dark matter, the mysterious and invisible substance that surrounds us, plays a crucial role in shaping the universe. In today's episode, we're exploring how dark matter has influenced the formation of galaxies and the large-scale structure of the cosmos. Welcome back to TerraNova. Let's start with a fundamental question. Why do we even think dark matter exists? It all began with what's known as the missing mass problem. Back in the 1930s, Swiss astronomer Fritz Zwicky was studying the Coma cluster, a massive cluster of galaxies. He realized that the galaxies were moving far too quickly to be held together by the mass of visible matter alone. There had to be something else, something invisible, exerting gravitational pull. To understand how dark matter shapes galaxies, we need to go back to the beginning of the universe, just after the Big Bang. In those early moments, the universe was a hot, dense, and nearly uniform soup of particles. But it wasn't perfectly uniform. Tiny fluctuations in density existed, and this is where dark matter comes in. Dark matter doesn't interact with light, but it does interact with gravity. Over billions of years, dark matter began to clump together under its own gravity, forming massive structures called dark matter halos. These halos acted as a sort of cosmic scaffold, pulling in regular matter, gas and dust, which eventually cooled and condensed to form galaxies. Without dark matter, the universe would look very different. Galaxies as we know them wouldn't exist because there wouldn't be enough gravitational pull to bring matter together. Dark matter, in a sense, is the invisible architect of the universe. Every galaxy, including our own Milky Way, sits inside a giant halo of dark matter. These halos extend far beyond the visible boundaries of the galaxy, and they're far more massive than the stars and gas we can see. While we can't observe dark matter directly, its gravitational effects are unmistakable. Dark matter halos don't just help galaxies form, they also help them survive. They keep galaxies stable, preventing stars from flying off into space as galaxies rotate. In fact, the rotational speed of galaxies was one of the first major clues that dark matter exists. Stars on the outskirts of galaxies are moving much faster than they should if only visible matter were holding them in place. So while we can't see dark matter, its gravitational influence acts like an invisible guardian, keeping galaxies intact. Dark matter doesn't just shape individual galaxies, it also shapes the entire large-scale structure of the universe. Galaxies aren't scattered randomly throughout space. Instead, they form along vast filaments of dark matter, creating what we call the cosmic web. These filaments are made of dark matter and stretch across the universe like the threads of a spider's web. Where the filaments intersect, we find galaxy clusters, dense regions filled with thousands of galaxies. In between these filaments are enormous cosmic voids, regions of almost empty space. The cosmic web, built by dark matter, is the backbone of the universe. In fact, large-scale simulations of the universe, like the Millennium simulation, have shown that without dark matter, the cosmic web wouldn't exist. It's dark matter's gravity that organizes the universe into this incredible structure, where galaxies and clusters form along the filaments. While dark matter itself is invisible, its gravitational effects can be observed in a phenomenon called gravitational lensing. This occurs when dark matter's gravity bends light from distant galaxies, distorting the image we see from Earth. One of the most famous examples of gravitational lensing is the Einstein cross. Here, a galaxy's dark matter halo is so massive that it bends the light from a distant quasar, splitting it into multiple images. By studying these distortions, scientists can map out the distribution of dark matter even though it's invisible. Gravitational lensing provides one of the most compelling pieces of evidence for dark matter's existence. It's like watching a cosmic magic trick where dark matter warps space itself, revealing its presence through the bending of light. From shaping galaxies to organizing the universe into a cosmic web, dark matter is the hidden force that binds the cosmos together. Without it, the universe as we know it wouldn't exist. But there's still so much we don't know. What do you think? Could dark matter hold even more mysteries we've yet to uncover? Make sure to like this video and subscribe to the channel for more deep dives into the mysteries of the cosmos. In our next episode, we'll explore how scientists are trying to detect dark matter directly, and whether we're getting closer to finally proving its existence.